Hello everyone. What we're going to do here is to see how we use Excel to calculate the range of feasibility. So once again, in a previous video, we've already calculated this by hand, and we found the range of feasibility for our acreage constraint and for our pesticide constraint. For acreage, we found it to be from a minimum of 5 acres to a maximum of 10 acres. For pesticide, we found from a minimum of 8 gallons to a maximum of 16 gallons. Those were our two ranges of feasibility. What we want to do now is to have Excel reinforce that work or double check that work for us, or see how we would use Excel in order to just make the calculation in general. Once again, I'm using work that I've already completed here. This is from last unit's solutions notes. I've already set up my linear program and solved it with Solver. So if I hadn't done that, I would need to absolutely go and make sure that I go and do that work. But whether I've done it or not, I've got it all set up. And even if I've already solved the solution like I have here, I'm going to need to resolve it with the use of Solver. Make sure all my inputs are still okay, which they all seem to be. That is still the right cell references. Everything looks good. So I click Solve, and I simply make sure that I click on the sensitivity report. After clicking on sensitivity and hitting OK, what we should find is that we now have a new tab at the bottom, letting us know that we've run a sensitivity report here, and they will simply be, if you do this for all your examples, they're just going to be labeled as report 1, report 2, report 3, and so on. Because this is the first report here, it is labeled as sensitivity report 1. Previously, we have seen this, and before we were dealing with the objective function. And when we're talking about the objective function, and that is up here in this portion that Excel has titled variable cells. So that deals with the objective function. Down here is what we're dealing with now, dealing with the constraints. And very much like what we saw before, we have initial values for our two constraints, acreage and pesticide, and we have an allowable increase and decrease. So in order to find the range of feasibility, I would simply take the initial value of 8, subtract off the maximum allowable decrease to find the low end limit, and then do the same thing. Take my initial value of 8 and add the maximum allowable increase to find the upper hand limit. And we're getting really happy here because it is backing up exactly the work that we did by hand. It is telling me that my range of feasibility, exactly like we found before, is from a minimum of 5 to a maximum of 10. And because I cell referenced again, I should be able to just simply copy and paste this down, making sure that the cell references copied over properly. So the initial value of 10 minus 2 to find the low hand limit, and the initial value of 10 plus 6 to find the high end limit. And just like we found by hand, the range of feasibility for the pesticide constraint should be from a low end of 8 gallons to a maximum value of 16 gallons. We also need to understand what this represents. As we work within the range of feasibility, and much like all sensitivity analysis, only one thing can change at a time. So if we had more or less acreage to plant and nothing else changed, the cost of everything stayed the same, the pesticide regulations stayed the same, the only thing that changed was we had either less or more land to plant, then we would not need to reformulate our entire model. What would stay the same is our two binding constraints. These two constraints, which are now binding, acreage and pesticide, would remain binding. My optimal solution would change, however, and my maximum profit in this case, or the minimum cost if it was a cost question, would also change. The only thing that remains the same as we stay within the range of feasibility is the two current binding constraints remain binding. So again, once we get good with Excel, we can double check our by hand work very quickly. And when we get the exact same answer both ways, we are pretty confident that we've done this work properly. Thank you very much, everyone. Please email me with any questions that you may have. And please check out the next video where I'm going to find the range of feasibility for the fertilizer situation, which will be a little more complex than the one that we've just found here. Thank you.